right, so we have made and isolated some soap from taking coconut oil and mixing it with lye in the presence of a little ethanol solvent. And after quite a long time of heating it, hopefully we had a nice complete reaction between the ester and the hydroxide to hydrolyze the three ester bonds and give us the sodium carboxylate, you might say, in general. And it depends which type of acids were in the fats. Sometimes there's oleic acid, stearic acid, then you get sodium oleate or sodium stearate, and each soap composition is going to be made of different sodium salts of carboxylic acids, so they're going to have different properties in terms of lathering and everything. So I took about 0.5 gram of each of the soaps. The soap I made today is this one, and it's got this really clean look to it. When I threw this snow white clumps that I made into this beaker and added some water, it floated, which I don't know if you're familiar with the legend of the ivory soap, but back in the day, somebody made a mistake when they were making ivory soap and blew it into the mold too quickly, and that trapped a lot of air in there. So one batch of ivory soap floated. Now, when people are washing things with the soap in a bucket or in a stream or something, and the soap floats, they can find it again. So people were really excited. They thought that was the best thing in soap technology, so they started intentionally blowing more air into the soap. But that's what this reminded me of, because when I put my snow white chunks into here, they floated at the top. And when this dissolved, you could see that it lathers a little bit as you just shake it up. Not a very persistent lather. It's very clear and very colorless, so a very clean looking feel to it. The commercial soap, Lever 2000, hasn't all dissolved. It's a little more off-white, like I don't know what color I would call that. Definitely off-white, like an ivory maybe. Strange. Ivory is almost pure white. Lever Brothers is more of an ivory. But in any case, it didn't all dissolve. I could probably heat it or do something else. But the lather is very, very persistent. So a lot of people like soaps that lather a lot, and this certainly is meeting that bill. It's not clear and colorless. It's got a slight ivory color to it, and it's very cloudy compared to the other one. So a lot of times as scientists, if you're going to compare two things, commercial product versus the product you made in the lab, you write down everything that's noticeable, the color, the clarity, the state of matter, the density, whether it floats or not, whether it sinks. They all might be really important in terms of the properties. I took a little bit of each solution so we can do a little qualitative test. So 2 of my coconut oil soap, coconut oil derived soap here, and I'm going to add a little phenolphthalein to one of them. Phenolphthalein is a great acid-base indicator, and if this is basic, it'll turn pink. Now, any sodium carboxylate, I would expect to turn pink here because the carboxylic acid is a weak acid. When you make the salt of that, you'll get a weak base. So I'm expecting that this will be certainly pink. This is so boldly pink, I would suspect that some of the sodium hydroxide, unreacted sodium hydroxide, got trapped in the cake, and that might be why it's so intensely pink, which we might want to, if we're going to try to sell this and market it, we might go ahead and mash it up and clean it with ice water to make sure the sodium hydroxide gets dissolved out of there. Now, by comparison, because this isn't a pH meter, we don't know the exact pH, I know that's basic for sure. Now let's check the commercial Lever 2000, and I throw a little bit of the phenolphthalein in there, and you'll notice this turns pink, but not quite as intense pink. It's very hard to tell side by side the comparison because of the cloudiness here. We're not seeing how much pink is all the way through the solution, but this is a little more, reminds me of an endpoint of a titration being closer to neutral, whereas this one makes it look like we overshot the titration and there's maybe a little extra base in there. So I might certainly, if I'm testing this for qualitative purposes, say, hey, if we want something that's going to be a little less harmful, we might want less sodium hydroxide in here, and find a process to grind it up and give it a better wash to make sure there's no excess sodium hydroxide trapped in there. The other thing that we might be concerned about is if we had unreacted fat, some coconut oil in there. But I think we get that when we go lather up with it. Is it going to feel really greasy? It might potentially feel greasy just because the solution of sodium hydroxide would feel greasy to your hands as well. So a lot of times your observation can have many different causes, but that's the type of thing you'd be interested in if you're into soap science, is it going to be basic enough to be caustic and corrosive, or is it going to be just mildly basic? In that case, not a big problem. The other test we're going to run here, other than the phenolphthalein test for basicity, so we're going to throw some calcium chloride in there. And calcium would be in hard water. So if you have very hard water, then you're going to have a lot of calcium there. And what calcium is notorious for is if you have very hard water, it'll diminish the usefulness of your soap because it'll precipitate the soap. And this is what the basic soap scum is. If on your shower or your bathtub, if you have very hard water, you're likely to have a buildup of this stuff from the calcium reacting with the carboxylic acid salt to make a new, less soluble carboxylic acid salt. And it might be useful to write a balanced reaction. Sodium carboxylate plus calcium chloride gives what? And the calcium salt is much less soluble. Now, I'm talking as if all salts are carboxylic acid anions. So you take the carboxylic acid, deprotonate to make the carboxylate. The sodium carboxylate is the traditional soap, but there's lots of other surfactants that people make that are more commercial, and they try to come up with formulations to reduce the amount of soap scum you might produce. This one, Lever 2000, has not obviously been engineered to reduce the amount of soap scum, because I throw the calcium salt into this one, and sure enough, we get a ton of the white chalky precipitate, so that either one of these, if you have hard water, would produce some soap scum. So that's just a normal chemical reaction we would see with most soaps, most traditional soaps, because the calcium carboxylates are not soluble. They produce this soap scum. So there's some of the fundamental tests I'm interested in. Our coconut oil-based soap seems to be very basic. Again, it precipitated so quickly, I think sodium hydroxide got trapped in there. And that would be a reasonable explanation. We could certainly test that idea by grinding it up, washing it really well with ice water, and seeing if the basicity is lower. And then in both cases, the Lever 2000 and our coconut oil-based handmade soap, we get quite a bit of precipitate when we add the calcium chloride to those. So some basic chemical tests, some observations of the different solutions we make with the soap and how they appear. Again, I love the snow white nature of the soap we made today. It floats, which is really cool. It might be a little on the basic side, but we're going to see how it lathers up in a minute. Okay, so one of the moment of truth kinds of things is we made this soap, pure white, beautiful soap, nice chunk of it from mixing coconut oil with lye in an ethanol solvent. And one of the things I want to find out is, does it act like soap? Is it going to lather? And the rest of that. So I've got a chunk here, and I'm just putting it in my hands and adding a little water like I would if I were washing my hands. This is going to be great for COVID-19. Get my hands washed for at least 20 seconds. And one of the things I'm really starting to enjoy here is we're getting a nice lather. And I guess in terms of characterizing lathers for soaps, is it big bubbles? You know, how hard do I have to work to get this to lather? This is a very rich feeling lather. It's very small bubbles. As you can see, it's not like foaming like crazy, but it's got a nice rich feel to it. It's sort of, I would almost describe it as creamy. And so I'm going to continue to generate some lather by adding a little water to the soap and, you know, massaging it in there like we would. Get the back of my hands, make sure I'm clean up to the wrist, both sides. Again, I like having a big bar of soap rather than this little piece, but this lathers well enough that even just a little piece, I managed to get this nice lather, and it feels super good. So definitely, if I were to buy a bar of this and give it a try, I would think this is really seems like a nice high quality soap that's giving me a high quality lather. It reminds me of when I've stayed occasionally in a very nice hotel and they have their specialty products. That's the kind of lathery feel that this gives me. And now I'm going to rinse it off. And see, my hands feel greasy at all? Because like I said, if I had done this too quickly when I was making the soap in the first place, there might be a lot of unreacted coconut oil in here that, again, then it would probably prevent it from lathering so nicely, and it would also give me a greasy feel like there was a lot of coconut oil left here. So as far as I could tell, my hands feel very nice and clean and not greasy. There's still some nice friction, my fingertips and everything. So I think it's a pretty good soap overall. And if we were going to make soaps with the cheaper vegetable oil and olive oil and this oil, and then try some of the commercial products, that's one of the things I would be really interested in. Do I like the way it lathers up? Do I like the feel of the lather? Did it feel like it cleaned my hands really well? And of course, one of the things I was thinking is I should have some greasy dirt here on my hands to see if it would battle a greasy dirt well. But at least with my normal, fairly clean hands, this seems like it's a great soap. And if somebody were to tell me this was soap and I tried it out, I'd believable. So it looks like the science still works. Coconut oil plus lye in an alcohol environment, heated for 30 minutes down to a thick paste, salt it out, we get a nice soap. And I keep emphasizing, if I wanted to clean this up, the large chunks probably captured more of the glycerin and more of the sodium hydroxide. If I really wanted a nice, clean, pure soap, I would probably be grinding it up, drying it, grinding it up into smaller particles, or even dissolving it and reprecipitating it slowly to make sure that only the soap precipitated and the other soluble stuff stayed in the aqueous solution. So overall, successful experiment, and I hope you learned something from this. Even it's, of course, I think much more fun and informative and memorable when I do things with my own hands and I make something, but at least watching the video should help you out with your understanding of the beauty and fascinating nature of organic chemistry.